Now we're going to learn how to write the equation of a rational function given its graph. So in this example, I have a function that has two vertical asymptotes and one horizontal asymptote in y equals -3, two different x-intercepts, and it passes through a specific point. So the first thing we have to remember is that vertical asymptotes are the zeros or factors of the denominator, and that the x-intercepts are the zeros or factors of the numerator. So if we have two vertical asymptotes, that means we're going to have two factors, either one, this one or this one, two factors in my denominator, and because we have two x-intercepts, that means we're going to have two factors in our numerator. That means that of all these options, the only viable option is this one. Two factors in the denominator, two factors in the denominator. So we can even start writing them. The first vertical asymptote is in -2, -3, -4, -5. So this would mean that this would be x plus 5, and the other one is in 1, 2, 3, 4, 5, 6, in x minus 6. Also, one x-intercept is in 1, -1, and the other x-intercept is in 3. Now that we have all of this, we know that the horizontal asymptote is in y equals -3. And because the horizontal asymptote is the division of leading coefficients, this means that a over 1 should be -3. So how much is a? A should be -3. So this is the answer. Another example. For this example again, let's notice we have two vertical asymptotes, and notice that we do not have an x-intercept. That is telling us that our function has to have two factors in the denominator, so it could be either one of these three options, but because we do not have an x-intercept, we know that that means that we cannot have a factor in the numerator. So options 4 and 5 are out of the list. That left us with option 3. So we can either start writing the asymptotes 1, 2, 3, 4, 5, 6. So one asymptote is in x equals -6, and the other one is in x equals -2. So I'm writing the proper factors. Then we know that because the numerator is of smaller degree than the denominator, the horizontal asymptote is in y equals 0, and the only thing we're missing is a. To find a, we're going to use the point through which we know our function passes. That means that if we substitute x and y in this function, we can find the value of a. So this is how we do it. We write our function in cardinal notation. Y equals a over x plus 6 times x plus 2. Let's substitute the values of x and of y into this equation to find the value of a. This means -1 equals a over -3 plus 6 minus 3 plus 2. Because if this point is in the graph and we force it into the function, we can find a value for a. This is a. So if I solve for a, this is going to be a over 3 times -1. So this is -1 equals a over -3. So if I want to solve for a, I just have to multiply both sides of the equation times -3. So on these sides, we have a, and -1 times minus 3, 3. So a should be 3. One last example. In this exercise, again, we have two vertical asymptotes, 1 in 2 and 1 in 6, meaning we can have one of these three possible answers. Then, we have an x-intercept in minus 3 and only one x-intercept, meaning that in our numerator we should have a factor. So that leaves us with only option 4. We can start writing the values we like. So this is x minus 2 and x minus 6. And the x-intercept is in minus 3, so this should be x plus 3. Now, the only thing we're missing is a. Again, because the horizontal asymptote passes through y equals 0, we can make use of a point that passes through the graph. So, if we write the function in cardinal notation, and substitute the coordinates for x and y, we can find or assign a value to a. So this would be minus 1 times a times 3 over minus 2 times minus 6. So that is minus 1 equals 3a over 12. And if I want to solve for a, I'm going to multiply on both sides of the equation times 12. And then I'm going to divide both sides of the equation times 3. So that leaves us with a being equal to minus 4. So here I write minus 4. And that is how you write the equation of a rational function given its graph.